The following KQED production was produced in high definition.
It's a pretty big stomping ground, this slice of cosmic real estate we call our solar system. Compared to the vastness of the cosmos, this place that Earth and its 7 neighboring planets consider home is downright cozy, and we feel safe here. But lurking out there in the darkness of space are millions of threatening strangers, asteroids made of rock and metal, and comets, which are largely ice and dust, that may be on a collision course with our planet, and could someday threaten the very survival of life on Earth.
If you had something 10 miles across, that is a mass extinction. At smaller sizes, for instance, something the size of a football field, then you could take out a city.
David Morrison is a senior scientist at NASA Ames Research Center in Mountain View, California. He's part of a small alliance of scientists around the world who are working to keep the Earth out of harm's way. Just a bunch of Chicken Littles paranoid that the sky is falling?
But it can't be as hopeless as all that.
Well, consider the long and tumultuous relationship between asteroids and our planet, and you'll understand just how important their work might be.
65 million years ago, at the peak of the age of the dinosaurs, an asteroid about the size of the San Francisco Bay crashed into what's now Mexico. The atmosphere turned as black as the darkest night for a year, and almost everything on Earth died. It was the most terrible event of the last 100 million years for life on Earth.
This massive object exploded with the force of 100 million megatons of TNT. But that was a really long time ago, and asteroids don't hit the Earth very often, right? Think again.
The impact we know most about, because it happened in historic time, was the Tunguska impact in June of 1908 in Siberia. And that was caused by an impactor perhaps 45 meters across. And it exploded in the atmosphere with the energy equivalent to a nuclear bomb, 15 megatons, destroyed a whole area of forest. So that happens approximately once every 500 to 1,000 years.
If an object like that hit the Earth near a populated area, an entire city could be destroyed and thousands of people would die. So what is out there heading our way? That's exactly what David Morrison hopes to find out.
The Space Guard survey has been going on now for 10 years, looking for near-Earth asteroids, and we found all the big ones. You keep looking at the sky over and over. The telescopes are surveying a big piece of the sky every night. There's nowhere to hide out there for a big one, but we certainly haven't found all the small ones.
It's late afternoon at the Chabot Space and Science Center, and astronomers Conrad Jung and Gerald McKeegan are embarking on a night of hunting high in the Oakland Hills. Their prey is elusive and distant. Their weapon of choice is a 36-inch reflecting telescope called Nellie.
The method we use for finding asteroids, we get a set of coordinates from the Minor Planet Center. We mount the camera on the telescope. We align the telescope. Yeah, we're good. So we can go ahead and go to the focus star. We'll take 3 images typically of the area where the asteroid is. Those images will be 6 or 7 minutes apart. And then we blink through them. If the asteroid is there, we'll see a little point of light moving across the screen. And then we'll analyze the location of it and report that data back to the Minor Planet Center.
The Minor Planet Center is an international body that tracks asteroids and comets. While most asteroids orbit the Sun within the main asteroid belt between Mars and Jupiter, some find their way into the inner solar system. It's the orbits of these rogue rocks that need to be closely monitored because a chance encounter with another object could knock that asteroid into a collision course with Earth.
Asteroid orbits can change due to gravitational interactions with planets, with moons, with other asteroids. And asteroids that are near-Earth asteroids, those orbits are actually unstable, so they don't stay in those orbits very long.
So, what happens when a killer asteroid is found with our address on it? Astronomers are debating that question in the hope of finding a solution before the next big one hits.
In the Space Guard survey, we've discovered about 6,000 near-Earth asteroids. And most of them are just no problem. One of them that didn't turn out immediately to be safe is the one named Apophis, which is named for the Egyptian god of chaos and destruction, because it will come very close to the Earth on Friday, April 13th of 2029. Miss us, but very close, and there is at least a possibility 7 years later that it will come back and hit us.
Scientists will be watching as this asteroid, roughly the size of a football field, approaches Earth in 2029 to see if it passes through a small corridor in space called a keyhole. If it does, the Earth's gravity will change the asteroid's orbit precisely so that when it comes back around again in 2036, it will collide with us. That impact would release more than 100,000 times the energy of the Hiroshima atomic bomb.
If we identify one that's going to hit us, we need to think about how we can mitigate that, how we can deflect it from hitting us.
Deflect an asteroid? Sounds like pushing over a skyscraper with your bare hands. Still, human history is filled with examples of the impossible rendered possible, like space travel. Rusty Schweickart is a retired astronaut who flew on Apollo 9 and is probably the world's leading expert on asteroid deflection, a fact that he finds appalling.
Everyone watching this program should be up in arms that me, an old astronaut, is a guy who's the world's expert. The world's expert on asteroid deflection ought to be in NASA. It ought to be in every space agency in the world. They ought to know a lot more about this than I do.
Frustrated with the lack of official discourse on the issue, Schweickart co-founded the B612 Foundation in 2002. Its goal is to help develop a way to alter an asteroid's orbit by 2015.
If we don't actually take some action now, at some point we won't be here anymore, because there's no question that we will be hit by asteroids unless we use the technology that we have and the brains that we have in order to protect the Earth from asteroid impacts. And we can do that.
The simplest way to defend against a small asteroid is simply run a rocket into it and let that change its orbit. If that doesn't work, then you have to think about other options, one of which is to take a big nuclear explosive and blow it apart.
Blowing up asteroids with nuclear weapons seems to be the method of choice in disaster films, like the 1998 blockbuster Armageddon.
Great Hollywood, but it's a lousy idea. You end up with, unfortunately, with a bunch of pieces of that asteroid, which can still hit the Earth, and now you can wipe out 3 cities. So you don't want to blow these up, and it's not necessary to blow them up. All you need to do is go up 10 years ahead of a potential impact or something on that order, and just gently push on them to change their orbit very, very slightly. And 10 years later, it'll miss the Earth instead of hitting it.
Making a small change in an asteroid's orbit is the basis of most deflection strategies, like the gravity tractor, a concept developed by the B612 Foundation. The gravity tractor is a spacecraft that hovers near an asteroid and gradually changes its speed, using nothing more than the gravitational attraction between the two bodies. The gravity tractor could therefore be used for limited but precise deflections, like causing Apophis to miss the keyhole in 2029.
When it comes to defending against asteroids, there's no one-size-fits-all. It will depend on what the asteroid's made of, how big it is, how much warning you have, and also, let's be frank, no real work, no serious work has been done to develop the technology to deflect an asteroid.
For the first time in our planet's 4.5 billion year history, we are able to detect near-Earth asteroids and predict their impact potential. And it's the only natural disaster that we can prevent. What's needed now is an international consensus on a process for dealing with the inevitable.
Well, these things happen so infrequently, why should we worry about them? Well, you and everyone watching this has about a 1 in 10,000 probability of having an automobile accident tomorrow. But the fact of the matter is you pay $3 to $4 tomorrow to insure your car against a loss. And yet we, as a planet, are driving around the solar system uninsured.
This insurance is the driving idea behind Schweikert's tireless work, lobbying international lawmakers and space agencies now, even though it may be decades before the next big one could hit.
In the next several years, because of new telescopes, we're going to be finding hundreds of times as many asteroids coming at us. And we're going to have to duck quite frequently. So it's the fact that those decisions are going to have to be made very frequently in the immediate future that forces us to start doing this work now.